I was reading recently a couple of papers about databases, data lakes, and I came to a conclusion that sometimes it's hard to understand the disadvantages of the databases, and therefore whenever we evaluate a database, we should ask a couple of questions. First, is it an open source or proprietary? Second, are we getting locked? Meaning, are we getting locked in specific features that would be hard to get out of? Third, is it a free database, or are we going to pay for it? 4 is a very important question. Why was it created? And are the reasons for its creation still exist? For example, if a database was created 10 years ago, and 10 years ago, the standard solution did not support a specific feature, and therefore this database was created, then maybe today we can go back to these standard databases as now they support this feature. So why was it created originally, and are the standard databases today support already these features? The next question is, how many components do we need to install? How simple is this database to manage? Because different databases can have different complexity in installation. Next question is whether this database requires a cloning of our data, whether it connects to existing data stores, whether it connects to the existing places where we store the data, or do we need to clone now the whole data set that we have? Because if we need to clone everything, then twice the storage. The next question is whether this database supports standard SQL. No matter how much we try to, or we convince ourselves that we do not need SQL, eventually we would need SQL. So I fully think that whichever database or data solution or data lake solution that we choose, we must see that it supports standard SQL. I cannot stress enough how important that is. And if someone tells you, yeah, it supports this flavor of SQL, but not the standard one, don't buy this. The next question is about latency. Gather as many information as you can. People have already done tests over the internet. Only eventually do your test, but you can collect a lot of data already from the internet, check the latency, and when you check the latency, check the differences in between the read and the writes and what this database was optimized for. The next question is whether it can support custom computations. Some databases will give you the result and that's it. But if there is a way to interact with the result, then we can apply on top of it additional calculations. In addition, if there is a way to get the intermediate results from the database, also raw data and not just summaries, different levels of aggregations, then this means we could apply additional layers of code in order to get different and custom computations. If the database will lock us and tell us, I have a few functions for you, sum, count, mean, and that's it, then it's not good enough. I want the raw data. I want whichever layer of data that I want. If I want the aggregations, I will ask you for the aggregations. If I want the raw data, I will ask the raw data. But I want to be in control and I don't want you to limit me. And why is that? Because there are solutions, there are good solutions today that give you both the raw data and the summary. So why compromise? 10 years ago, maybe we wanted to compromise, but not today. The next question is whether it focuses on write, on read. Is it efficient on both or only on one of them? The next question is to check exactly how many years ago was this solution created. Because if this solution was created 10 years ago, and 10 years ago, there was actually this need, so this solution was created. But today, the standard solutions already made progress such that we can just use standard solutions. Or just plug in on top of standard relational databases. which can give us the additional benefits. So rather than going to an obscure database, we could use standard solutions, which would be better.